Now first let me show that cylinder. This is a cylinder and this is the inclined plane. This is the center of the sphere. Okay, let's try to have diagram like this. Weight of the cylinder will act here, mg, and at this particular point, a string is suspended here, no? And using this, a particle, mg, so therefore here tension T will come. And this is a point of contact. This is a O, this is a E. Keep it this much here. Now it's an equilibrium cylinder. A light string is tied to cylinder's rightmost point and the mass m hangs here. Assume that the quotient of friction between cylinder and plane is sufficiently large to prevent slipping. There's also friction is there. So in what action the friction should act here? No. The direction of friction also not given. This is theta. How to predict the direction of friction? Let's take about point O. About point O, what is the torque? Torque about an axis passing through point O perpendicular to plane. What is the torque due to mg? Will be 0 due to weight of cylinder. Torque due to this tension. Tension will act away from the body. And we know that T must be equal to mg. Small mg. Is it clear? Because everything is in equilibrium. And then let's go for torque about point O. The tension will set up clockwise torque. Then it's an equilibrium means somebody should set up anti-clockwise torque. Sir, why can't normal reaction? Yes, okay, very good. The normal reaction between the cylinder and the inclined plane, how it should act? It should act perpendicular to this. So what is the torque about O due to mg and n? Will be 0, no? Because they'll intersect axis of rotation. So therefore, there must be somebody anti-clockwise torque. So therefore, it must be a friction. So how the friction will act? Will act in this direction. This is a method of working on the problem. Because in equilibrium, torque due to tension will be clockwise. Torque due to friction should be anti-clockwise. So the friction should act up the incline on the cylinder. Okay, now, but what is our question? What should be the value of small m is asking? That was our only thing. How to bring that? I'll take help of the condition here. So this is the, what can be this value, theta, and this will be theta. This distance OP is R, no? OA equal to OP equal to R. So let me take this distance as X. The remaining distance, how much it will be? R minus X. Now, torque about point P, let me directly go for torque about point P. Torque about point P, about an axis passing through point P perpendicular to plane. Always assume that in which plane the body is lying. The diagram is in XY plane, so therefore Z axis will be perpendicular. So torque about an axis passing through point P perpendicular to plane. TPZ, this should be called net torque. Wall will set up. Torque due to normal reaction and friction will be 0, no? They'll intersect axis of rotation. Torque due to tension about point P, T into X. Clockwise. Then torque due to weight, mg r minus x will be anti-clockwise. As in equilibrium, net torque should be 0. So therefore, this will be Tx. And what is T further? Small mg. Can we define anything r minus x as sine theta? What you can write it as from the triangle? R minus x by r. So we don't know value of x. So we'll calculate that value of x here from this. And that I'll substitute here. So this will be r sine theta equal to r minus x equal to r1 minus sine theta. I'll substitute the value of x, r into 1 minus sine theta. This will be negative. Mg, r minus x is what? Only r sine theta. This should be equal to m sine theta by 1 minus sine theta. This answer, it's very simple. A student should put effort here. See, rotation mechanics is the very easiest chapter. Maybe the books or the earlier teachers might have said something for you. According to me, it's the easiest chapter. Provided what pen, you must have that approach in a very systematic way. Sir, now you can ask questions. Sir, I want that friction also. Anyway, you didn't ask. Let's calculate that friction. Can we calculate that friction? Because I know now M. So talk about O, I'll go for it. Talk about axis passing through O. Then talk by N and Mg will be 0. Here what why normal contact has not come into picture? Because N and F will intersect axis passing through point P. That's why only torque due to tension and the weight of the cylinder has come into picture. Now talk about O, about axis passing through a perpendicular to plane. Due to N and Mg will be 0. Due to tension, T into R. Then due to friction, F into R. So this should be equal to how much now? 0 minus TR into FR.